brown-eyed woman, and they have 8 children, and the children are all brown-eyed. What are the genotypes of the children in the family? So these are past paper questions that are just copied and pasted, and I have no clue of the solutions, just like you. Yeah, so basically we're going to discuss together and find the solution. Yeah, so the question is saying a brown-eyed. Yeah, I've even read the question. So what's your take on question number 59? This is from 2011 paper. What's your take on question number 59? Hello, can someone? We have a lot of questions, so we're not going to spend a lot of time on one question. If one question seems like we're spending a lot of time on it, we'll be jumping the. Okay, Doc Byton is saying one. Why are you going with one, Doc?
I think they've got a heterozygous dominant one. The other, which is of their color, because they're telling us their color is they are all brown. So meaning genetically that is just phenotypically, but genetically these guys, they are heterozygous. They are not really as brown as they are. So they are comprised of brown and also blue. Meaning number one is the right answer.
Okay. Okay. Thank you for that, Doc. Okay. So you're practically saying the parent also has some. The children also have some blue-eyed in them, isn't it?
Exactly.
But again, there, when you look at the question, it says that and they have 8 children, all brown-eyed. So I was thinking that the brown-eyed man or the father's color was dominant, and yeah, since all the 8 children had brown eyes, so I think there the dominant color is brown. Okay, like for me, I think the answer is two, homozygous for the dominant allele for brown eyes. So I don't.
Okay.
We are dealing with
No,
the children
no.
here.
Just the
Dr. Rosemary,
prosperity.
you just mentioned the correctly. She was just okay. She mentioned everything correctly, but now she says it's dominant. Then you go and say homozygous for brown eyes. You know what is there is if these are brown, meaning brown is the only one which is being shown outside. Okay, for instance, there are people whom you can see to be very tall and kanshi mukati tunango tufupi fupi. You are going to discover that from their cross section, from their cross breeding with the wife, such that you are going to discover kanshi mwina mafupi umu. So this is what was happening here. This one has got brown. The brown was dominant, we understand, and that is true. But the mother had the blue eyes. So all the children are going to be brown phenotypically, but genetically, these individuals are what? They are heterozygous.
And I think what you've said, Dr. Rosemary, I think it works for parents. Like what you've said, yes, everything is correct. But here we are dealing about the genotypes for children. So what you've said for parents, yes, is true. But now when you take it to the children,
Okay. Thank you for that, Doc. Then what makes 4 wrong? Hello.
For four is wrong, completely wrong, because it is
Okay.
telling us that some are this and some are this. Meanwhile, from the question they've said all are brown.
Okay. Thank you very much for that. Exactly. So the best option there
And
is to go with one. Yes, Doc Prosperity.
I'm thinking, considering that if we take brown to be a big baby, we get baby this side and the blue small baby which are recessive this side for the mother. It means that when you cross,
Mm-hmm.
it's more like there will be no children who will be having blue because the blue is for the mother and the blue is for the father. They'll all be having blue and they'll be having brown as the dominant one and the recessive the blue one.
Exactly. Okay, thank you for that. The question was just more of you cross what? Let me say maybe you cross double BB with small BBs. So basically that was a cross in there. More like a test cross.
Crossbreed, right?
Okay, we can go on question number 64. And number 64 is saying the disease hemophilia is sex linked and recessive at the same time. A normal man marries a woman who is a normal man marries a woman who is hemophilic. What phenotypes will the children probably have? What phenotype will the children probably have? So this question is based on uh, sex linked genes or diseases in other cases. Yeah. So it's a question from Bao 1412 exam 2012. I think so. That's where I got it from. Okay. So what's your take on question number 64? What's your take on question number 54? Okay.
I think they're all going to be normal, but carriers. Okay.
Okay. Why do you go with all of them being normal in the areas? Eh?
What I'm looking at is the father is normal, okay? The parent is this father, a man, is normal.
Mhm.
And the mother, we are told that hemophilia is a sex linked gene, which is recessive, okay? So it is not dominant, it is going to be there in whichever, in whosoever is there, it's going to be dominant, it's going to be present, but it's not going to show up as a dominant. So
Okay.
all these yes are normal, but they are carriers.
I know these are normal, but they're what?
They are carriers.
Okay.
A normal man. We're just looking at a normal man and the carrier. Don't confuse.
But okay, before I get that, anyone else?
Doc, I don't know if it's my network or what. The questions are not clear.
The questions
Try
are
to
not
log
what?
out and log in.
Yes, I
They
think.
are not clear, like I can't see proper.
Log out and log in.
Okay. Welcome, Doc Maxwell. I think this is your first meeting, huh? Welcome. Welcome to SILILOCONNECT community. Um, Doc, is it Doc Sydney is going with option C? Yes, Doc, why are you going with option C?
Parisiap.
I think using the concept that I know a concept from
Three.
grade 12, since a male usually have XY, and then a woman is having XX, and a person can be hemophilic if
Mm-hmm.
if the small letter H is actually
Mm-hmm.
on the X. So looking at the man there, since the man has got the X and Y, so it means that since the woman is the one who is suffering, so it means that there is a high chance, there is 100% chance of all male children being hemophilic. I think so.
And what happens to their female children?
Okay. Thank you. Anyone else? Anyone else? The skin just for a minute so that we Do not. Okay. You get back to the sharing of the screen. And I'm back.
Ni sure.
Okay, where is my screen? It's been long when I did my emotion. The expression you use is this one. Okay. H is for normal. And small letter h is for hemophilia. How do you even spell it? Is it A? Hemophilia, something like this.
Hemophilia.
Whatever, sir.
Hemophilia from the Tonga
It's
pronunciation.
EA.
You will never find a man. You never.
I've seen why Faith is complaining of your network. Because your network is bad. You will never find. Continue.
Find a male who is a carrier for hemophilia. Meaning, is hemophilic, huh? You know that normal usually, you know that when you talk about normal, I didn't say she's a carrier. So it means she has double H, small letter H. If she was a carrier, they could have had, we could have a capital H. Now they said she's hemophilic, meaning she's not a carrier, but she has hemophilia. So we're not going to put a double H. We're just going to put two small my H. So like our president. Then when we cross it, you're going to cross it with a male. I don't know. I hope you not get confused with this extra foot up. You're going to cross this woman with a male who is normal. So meaning the male has the capital letter H and he just has Y. Y is never involved in this process. Y is just an innocent here. So we're going to cross them now. We're going to cross them. When you cross them, you're going to have. I want you to be seeing the children, in fact, because this one is because the capital H is dominant, you're going to have first capital letter H. Then a carrier. You're seeing, Then, hello, can I get the feedback?
Tumvera anko.
Yes.
Okay, thank you. Then the other one is going to be. Then the other is going to be what? Is going to be. It means this one is going to be what? Isn't it? Then the same process happens the other way foot. When we cross this one, it comes this side. You're going to have X with a capital H. So in short, before I even went, what we have this side, because what we have found up is what we're going to find this side, because why are you going to find the same thing? Is because these two are the same, right? So even if I cross, I'm going to have a carrier. I'm going to have a carrier, a female carrier, and I'm also going to have a male hemophilic child. So basically, in short, what it means is all the female are going to be what? Carriers, then all the male are going to be what? Hemophilic. That's the solution to that question. So you check your options that you have. I think someone had already given us the answer. I just wanted you guys to kind of see the concept there. Okay, Doc, you can share now. Hello, Doc Cyril. Thank you. Okay, so on the options that we have been given, according to what we have agreed on, what's the best option there? In fact, it was even marked. Yeah. So option 3 is the answer we're going to go with. I hope we have all gotten the concept there.
Sure.
Okay, thank you. We can now go on question 58. Can now go on question 58. Okay, I have the sun. Unless when I go no one neighbor, but not from the man. Question 58. Chromosomes align themselves at the equatorial plane of the spindle fibers. Attached to the spindles by the centromere. Which stage of cell division does this statement refer to? Which statement? When chromosomes align themselves at the equatorial plane of the spindle fiber, attached to the spindle and the spindle fiber, so not of, but in the spindle fiber attached to the spindles by the centromere. What stage of cell division does this statement refer to? Number 1. So, Doc, why do you go with option number 1? Why has your heart desired number 1, Dr. Thomas? Oh, can I get a feedback on question number 58? Two. Okay, Doc Moses goes with it with yes, Doc Moses. Why are you going with the metaphase of both mitosis and meiosis? No, Dokani, the answer we went with is option 3 on the biggest question. Oh, can someone guide us on question number 58? Which option are you going with? Imagine this question came in an exam. Are you going to go with 6?
I think the answer is
Maybe my network has
number
cut.
4. Metaphase 1 and 2.
To answer.
Okay, the reason being is
Metaphase
that
2.
let me read the reason first.
Yes, Dr. Rosemary.
Okay, so the key difference between metaphase 1 and 2 is that in metaphase 1, homologous chromosomes pair up at the metaphase plate, while in metaphase 2, single chromosomes line up at the metaphase plate. Hence, metaphase is the stage of cell division in which the chromosomes arrange along the metaphase plate. So, I don't know.
Okay, thank you very much for that, Doc.
I think you've removed the option. I think it's metaphase 2. Because there, we've seen that in metaphase 1, chromosomes pair up. And then in metaphase 2, chromosomes are like they align in a straight line. So in our question, we've got the word align there. So
Yes.
Doc, metaphase 3.
Okay.
that's why I think that was metaphase 2 because there's align, not pair up.
Okay.
She's correct. I think what?
Yes, someone else is saying what?
Metaphase 2 is correct.
Metaphase 2?
Yes, metaphase
Okay.
2.
I think from my side, I feel like Dr. Rosberg has explained everything on this one. If the question had mitosis, we could have. Sorry, if it question at the metaphase just, we could have considered that one. But there is no metaphase up. And you can't go for 5 of say metaphase of both mitosis and meiosis. Because meiosis has 2 types of metaphase, so that wouldn't make sense. Anaphase talks about chromosomes not aligning but going away. And metaphase 1 and 2 are not the same. Just like Dr. Roseman has explained. One is responsible for paired upward chromosomes, and we're only looking at chromosomes, not homologous chromosomes, but chromosomes. That was the key term, right? Chromosomes. And Dr. Roseman has explained nice on this one. I don't think we should waste time on it. So on number 58, whoever was marked the wrong one. The answer is supposed to be 2. Metaphase 2 of, and I don't know what this statement meant of one. You can't get me. Hello?
Oh, yeah.
Me, I can get
Hello?
you.
We are getting
We
you,
can
Doc.
Can't
get
get me, or maybe it's a network. Okay, thank you very much. Doc, you can just try to log out and log in. I feel maybe your network has tripped somewhere. Okay, we're going to look at question number 34. We're moving now to question number 34. Okay, we still have some questions. When there's
Wait,
deuterium
before we
ion,
move, what's
okay,
the
so now I've now
conclusion
moved
on
away from
58?
bar 1. Okay, 58. We have gone with option 2. That's what we have agreed on. You can get yourself. I don't know if I've answered you, Dr. Rufia, but we have gone with option number 2. That's the option we have gone with as people's choice. Option number 2.
All right, thank you.
Yes. Okay. Okay, you're welcome. Option. So we're now going on question number 34. We are moving away from bar 1412. We're now going to bar 1401 now. We are now doing bar 1401. So bar 1401, this is where we're getting this question from. When a deuterium ion of amino acid is pressed in an alkaline solution, the dash amino acid. Okay, those are the options. On question number 34, what's your answer preference on question number 34? Even the person who was marking was confused. He marked everything. So I don't know which answer he chose for the exam. I'm sure I went with 6 this one. So what's the option on number 34? What's the choice? Hello? Hello? My network is cutting too much today. So even if you're not answering, you should just be responding to give me a signal that you people can get me. Okay. Thinking in process.
We're
Okay.
getting you. Yes.
Okay. Let me give you some time to digest the question then. Then you come up, you tell me. Okay, thank you. Okay, let me digest the question as well. As you're digesting. You just come up when you tell me what the answer you have chosen. I think I've seen this question in most past papers. Like they usually ask it and they will just rephrase it in a different way. They'll just play around with English on this question. Okay. Doc Maxwell is going with option 4. Doc Maxwell, why are you going with the option number 4? Why is the answer preference option 4, Doc? So that we also choose option 4 as well. Give us your manifesto for option number 4. So that we vote for it as well. Okay, so the remaining is 12 minutes to end the meeting. Can someone come up so that we don't just solve 2 questions, then we call it a day, a night, sorry. Hello.
Okay, I think let's just debate on the option 1 and 2, because we know that the tellurium ion of amino acids, there are those amino acids which have the what, which behaves as if it is an acid or as if it is a base, depending on the medium or the solution in which it is where it is. Yeah. So if we look at option 1, we have amino group becomes positively charged, but actually we know that the alkaline solution, if we place this deuterium ion, so this amino acid will behave as if it is an acid. So meaning we are going to have it is going to be positively charged, but we know that the acid is a proton donor, meaning it will donate 1 proton, which is the hydrogen proton. So I don't know now how we can analyze about option 1 and 2.
Okay, I was just checking in the WhatsApp group. Dr. Kasha sent something on. You can watch it. Internett's explanation on cell cycle after the meeting. Just check it out. The guy did a good job on that. Okay. Then option. Okay. Dr. Bethel, did you go with 2 or 1? Which one was the answer preference? Okay. So the trick there is when you see 1 and 2 are practically the same. So how you can know the answer to this question number 34, even if you have no idea, is by just using tricks of biology. When you see 1 and 2 are the same, so it means yes.
Can I just read something on this question? Let me just read something on this question. I don't know the answer as well, but let me just read something to open up our minds a bit.
Thank you very much. Yes,
Okay.
you can carry on.
Okay, so if an acid is added to a solution containing the deuterium, the carboxylate group captures a hydrogen ion, and the amino acid becomes positively charged. If a base is added, ion removal of the hydrogen ion from the amino group of the deuterium produces a negatively charged amino acid. So there, I don't think option 1 can be the answer, because according to this explanation that I've just read, it says if a base is added, ion removal of the hydrogen ion from the amino group of the deuterium produces a negatively charged amino acid. So now, yeah, I don't know if the statement makes a bit of sense.
It makes a lot of sense. If you want to understand this whole question nicely, and when it's how you can understand it nicely and how you can get the concept. If you just go and check Shatter's notes, like the first notes on bar 14001, I think it did a good job on this one. So the issue there is, like I had said, even if you didn't know what to do on question number 34, you can just use tricks of biology. Number 1 and number 2 are practically the same. They mean the same thing. So it means you cannot choose 1 and 2 because on the options there is no 1 and 2 above are correct. So if 1 and 2 have been put on this question and they are there just to trick you, it means the correct answer to this question is something that is opposite to 1 and 2. So when you check everything that has been given as the options, which one is opposite to 1 and 2? Yeah.
Okay, first of all, what does
Answer
it
there
mean
is
when they
option
say
number 3.
the amino acid?
It is the one that is opposite to 1 and 2. Why am I saying 1 and 2 are the same? Look at number 2. Number 2 is saying amino group loses a hydrogen atom to the solution. When an amino group loses a hydrogen atom, so when they say something is neutral, basically it means, like we say water is neutral, right? It means it's something that can have two things at the same time. When I'm neutral, it means I cannot support you. I cannot, at the same time, I cannot support Doxydo. I'm just on the middle. So basically, that's the characteristic that amino acids have when they are in a pH that is at 7, or let's say, for example, they are in water. The pH there is 7. So the amino acids are going to have two charges. They're going to have two charges, and that condition is called an amphion, something like an amphion, yes, or the dipolar nature of amino acids. They will have two charges at the same time. They will have the positive side and the negative side. I think we also did this when we're doing acid-base equilibrium, where we are saying it will act like a buffer there because of that amphion or dipolar or the nature of the amino acid. So basically what I'm trying to say is, initially an amino acid is at pH 7. And then if you take the amino acid, you put it in a medium that contains a lot of hydrogen. I want you to follow me on this one. A medium is called an acidic medium because it contains a lot of hydrogen. So when you take an amino acid and you put it in a medium that contains a lot of hydrogen, it will act like a buffer. Act like a buffer how? It means that amino acid is going to gain. I don't know if you're getting me on that one. It's going to gain the hydrogens from the mixture to act like it's stabilizing itself. And as it's gaining the hydrogen, it is losing electrons. So I'm actually talking about two things. I'm actually talking of two things in terms of I'm using the Bronsted-Lowry theory and the Lewis theory of acids and bases. So as it gains hydrogen, it loses some of the electrons. And when we know that and we know that when a molecule loses electrons, what is going to happen to its structure? It's going to have a positive sign to it. So this is the reason why when you put an amino acid in an acidic media, the amino acid is going to be positively charged. Then now let me go to the point of an alkaline solution. An alkaline solution is a solution that contains less hydrogen. So what is going to happen when you take an amino acid in a solution that contains little or no hydrogen? It is going to try to make the solution acidic. How is it going to do that? It's by losing the hydrogen it has from the acidic part of it. So it's going to lose hydrogen when it's put in an alkaline media. And when it does what? And when it loses hydrogen, it gains electrons. So you're seeing there's opposite of what I'm saying. I've talked about losing and gaining. So when it's in an alkaline media, it loses hydrogen, and when it loses hydrogen, it gains electrons. And when it gains electrons, what charge is it going to have? It becomes an anion. It's going to become negatively charged. So based on what I've said, what option are you going to go with on question number 34? So like I said, before I even explained, I said basically when you look at just these are just tricks of biology. When you look at one and two are the same. So if you see one and two are the same, just look for something that is opposite to one and two. And the best answer was option number 3. Because option number 4 is saying what? Amino acid becomes electrically neutral. How can it be neutral in an alkaline solution? That can't happen. It only becomes neutral in a neutral solution, so to say, pH 7. Number 5, amino acid. In fact, we don't even say it's neutral because it says dipolar, not neutral actually. Number 5, amino acid develops both positive and negative charge. So option 5 and option 4, we can put it under pH of 7. Then 1 and 2, it's pH less than 7. So yeah, it's pH less than 7. Then 3 is pH greater than 7. So the best answer there is option number 3. Unless there are questions there. Hello.
Yeah, it makes sense now.
Okay, thank you. So just like I said, this question usually comes in different ways. They'll just rephrase it and put it in different ways. So, oh, that question was answered on the hive. Okay, it's quite important for what was the solution to on the hive. Is it the same one? Doxidiro. Hello. Is it possible that you
Yes,
can?
Dr. It's incredible with the explanation. Let me try to go and pick the
Okay.
explanation there. Then I put it in.
Okay. Thank you. Okay. So just like I said, this question is just usually rephrased in different ways. So it's quite important for you to know it. So I would advise you just to go and take Dr. Shatter's notes. I think he did a good job with explaining on what actually happens. Then let's look at question number 35. Question number 35. Why do proteins go into a choroidal solution in cytoplasm with a pH of 6? The isometric electric point of the amino acid is pH 8. I think I don't have any idea on question number 35. What's the solution on question number 35? So let's be fast. We're only remaining with 10 minutes to the end of the meeting. Okay, as you're analyzing, let's check out of time. We'll check up on the time because we have only a few minutes. So what's your take on question number 35? Okay. Choroid, I repeat. Choroid comes from the term choroidin, I would say. Is it? Choroid. Hmm. Yeah, choroidin actually. Exactly, yes, choroidin. Yeah, I think I've seen the answer to this question. So based on what I've explained, you should see the answer on question number 35. Okay, you're welcome. I do think proteins alive.
Question nangu.
Ndio masiksa. Nunga mache 6 mwangazi kabisa.
But I think I would guess positively charged too.
Okay.
Or what I know is that choroids are usually positively charged. I mean, not positively, but they are charged. Isoelectric point. Equal electrical point. Iso means equal sharpness. So isoelectrical point is just the equal point of electrical flow. The flow of charge is equal.
Okay. Okay,
Yes.
sharpness here. So now, how is
Sharpness.
the isoelectric point? How is it helping us, the isoelectric point? Because I've already heard you talking about eco. Eco, what has eco done? I just said
What
eco,
has
eco,
equal
eco
done?
what? Eco, eco.
Uncle,
Okay, thank you very
where
much for
these
that,
people are
Dr.
comparing
Zemba.
me.
I think Dr. Zemba has done a good thing, right? Yeah, that's explained nicely. The isoelectric point is the pH at which a particular molecule carries no net charge, no net electrical charge. So just like what Dr. Chazemba said, no net electrical charge. So it means that pH of 6, they have what? They have a charge actually. Thank you for that, Doc. I think what the doc has said should even give us an idea of what the answer should be.
Now,
Okay, Mark is
what
an
should be the
exam.
answer? Because me, I know it's going to be positively charged. But don't ask me why. I
Anyone
don't
else?
know.
Yeah, exactly. Anyone else to support Dr. Kakashi or to to come out with what? With a powerful evidence why Dr. Kakashi is not giving us a great answer. Yeah. Stop helping us imagine. Make a fiction. Okay, I think we are going to waste a lot of time on this one. Okay, so the answer there is just like I'd said these questions are just rephrased differently usually.
Hello, poison in
Okay,
California.
Okay, sorry about that. Yeah, so
Doc.
I think yes, doc.
Yes, I don't know, but I stand to be corrected. I'm thinking 3 is correct. I say that because
Okay,
it has some kind of attracting, and then when things are colliding, I think they should be somehow attracting. And then when things are apart, they must be somehow repelling. So, because of the attracting word here, I think I would go for 3.
okay, okay. Thank you,
Hello?
thank you for that. Okay,
Doc,
okay.
excuse me.
Yes, doc. Yes, doc. Conrad,
Yeah,
you can come
yes,
in.
yes, the correct answer there is 5 because
Okay,
at pH of 8, all proteins dissolve.
okay. Yes, explain to us, doc. Why you going with why all proteins dissolve at pH of 8, and why should be the answer pH of 8 at dissolve? Now I'm quite confused. They dissolve in what? Okay. Remember what I had said earlier when I was explaining on 34. I said this question
What have
is
you
the.
concluded, Uncle? I was logged out.
Papa, I'm making a conclusion. You're just in time. So I was saying this question is just
Oh,
rephrased differently. So the issue is
hope you
just
are saying the
you to
answer is
know
positive.
when. Yes. So I was saying the most important thing is for you to know when a protein or an amino, sorry, when an amino acid is when an amino acid is either negative or positive. That's what I said. That's the most important thing. So now let's look at this question. Why do proteins go into a colloidal solution? So what you understand by the term colloidal, if you did we did chemical kinetics, it should be chemical kinetics. When we're talking of the issue of making my what was this? We're talking about before we brought in the issue of my enzymes. We're saying for there to be a reaction, we're going to look at the issue of corrosion and stuff like that. But away from chemical kinetics, my point there is what makes something to corrode punkana is, let me say I'm negative, then I find someone who is also negative. Me and that person cannot attract. So that repulsion force that I will have, I will repel that person, and that person who is also negative will also go and find someone who is negative and azamupunga uja. And the process will be more like zamba cho kupunga na pungana because we basically have the same charge, isn't it? But if someone was negative and I'm positive, it means attack. Now when you look at option number 3, because they are all electrically neutral and therefore attract. So this statement electrically neutral makes this whole statement number 3 to be a wrong statement. Something that is neutral cannot attract. How can they attract when there is no attraction between them? Sodium and chlorine can attract because there is negative and positive, isn't it? Okay. Then when you look at okay, when you look at 1 and 2, that's why I'm okay. Doc Byton, before I continue, Doc Byton is saying, no, hydrophobic part which might repel film. Yeah, so just like I was saying, the main point there was just to realize what happens when amino acids are in a pH of less than 6. So this point was to tell you that the isoelectric point of the amino acid is pH 8. And just like Dr. Zemba said, amino acids in pH of 8 are electrically neutral because we're talking about the transition of 7 to 7 is dipolar. And we're saying at 8, they are having the issue of being electrically neutral at some point. They are not negative, they're not positive, they're actually acting like neutral. So a pH greater than 9, greater than 8 will make them to be what? To be negatively charged, like question 34 was saying. Then of a pH less than 8, which is pH of 6, will make them to be positively charged. And even they're positively charged, they're going to repel. And when they repel, what is going to happen? They're going to cause corrosion or corroding in them because they're all negative. So they'll pungana because they can't attract to make one thing up together. I don't know if you have gotten me on that one, but that's my analysis on this question. Unless there are other views, we can move to question 36. Unless there are other views.
Sorry for taking you back. I logged out. So you said the colloidal solution in feature.
I was breaking. I was saying, okay, a colloidal solution is a solution. Colloidal coming from collision or colliding. So when you talk about collision solution, meaning it's a solution where they're just colliding. There's nothing like they are doing what they have attract. There's a difference between an attractive solution and a colliding solution, so to say. It's more of atoms that are not of the same charge. Then pungana. They have not attracted to make one. They are not attracted to make one thing. Let me talk of the way particles are in a solid and the way particles are in a gas. particles in a gas are in a colloidal solution, and the particles in a solid are in a I would say in an attractive solution, or in an attraction solution, so to say. I don't know if you've gotten the example. So think of, when you talk about colloidal, think of gases. The way gases more pungana, something like that.
Okay, so
Have
which
I
one is the
answered
best
your
option?
question? So the best option is 2.
Sorry.
2. Is it 2?
All right.
Yes.
Me too.
Okay, thank you very much.
Yes. Yes, it's 2. So remember, I said it's very important for you to know this one. I just rephrase the question in different ways, but it's basically just the same concept of knowing when the amino acid is negative and when it is positive. We can go on question number 36 if there are no questions.
Hello, Dr. Kechi,
Which
can
of
I
the
add on
following?
something here?
Yes, Dr. Shuton, you can come in.
Yes, for me, how I can able to answer this question. So about, if I check about what's this, proteins, like let's say for example, amino acids, they are like okay, they have got a polar, okay, in short, they have got what's this, it inside the base it is negative, but outside it is positive. So I was able to think in this way that they are positive, proteins outside they are positive, so they are can able to repel each other. In short, like the way you have said, in a pH of 8, they are positive because they are.
Okay.
Shooting, you know.
Your voice, Dr. Shuton. Okay, thank you very much. Exactly like the way as Dr. Shuton has added on. Yeah, exactly. So the positive acid, negative alkaline. I don't know how you're going to remember them or squat them, but that's the case. Question number 36. Which of the following sets of words are complementary? Which of the following words are complementary? Protein, ester bond. So I think this one we're just going to do fast. What's your take on question number 36? What's your option on number 36? Hello?
3.
3. Okay, thank you. Option 3 is the correct one. Condensation is a loss of water. So yeah, that's the option there. Option 37. On the shelf of groceries in a shop, fats are in dash form. On the shelf of groceries, I think we all go home shops. Do we?
I think the answer
Kwatu wetu ntemba namka ntemba nsema
I'm going to
okay,
say mango.
okay, again, we can't say that. Okay, I'm contradicting my answers. There we've got solid and liquid. In shops, we've got cooking oil, which is saturated. Is it saturated? And then we've got butter as well. Because in terms of fats, we've got saturated fats and unsaturated fats. So if we go in shops, what do we find? I think that's what the question is asking. So I don't know, Poka.
Doc,
well done,
what do
Dr.
you call fat?
Rosemary. I think for us to answer this question, we should look at how does fats behave at room temperature. I think that's the only thing that is going to help us.
Yes.
Yeah, it's room temperature, and usually, I think I just sent this concept from Monza, right? Because my view was I never used to even think of masala as fats. Those are what we call them oils.
They are fatty oils, uncle.
Exactly. So the issue there is when lipids can be in two forms. Huh? Yeah, lipids can be two forms. We have two. What makes lipids are in two forms? We have oils and fats. A combination of oils and fats make lipids. So when you see a question talking about oils, that's when you think about liquid. But when they talk about fats, think about solid. So the answer there is 2. unless otherwise, but it's 2.
Solid.
Yes,
Wait,
solid.
what does it mean? Wait, before you go to the other question, Dr. Akash said room temperature. What did he mean when he said room temperature? Like mushop, mozi zira nangu, or
So, okay, Dr. Akash, can you come in this because you're the one that brought it up.
They put under the sun. That one is not room temperature.
What can be kept at the room
You
temperature?
find butter and cooking oil are both liquid.
At 24 degrees Celsius.
Katemba. Katemba, kenkabe mutenge. That is not room temperature. That's not room temperature.
It is the one recommended at the periodic table. That's the room temperature.
Exactly. Thank you very much, Doc. So when you talk about when you talk about room temperature and pressure, we're talking about 1 atm and we're also talking about, is it 25 degrees Celsius or 271?
Well,
271
tell us
Kelvin.
whether it is hot or cold. Mambolta explain verse, we're more confused now.
Okay, let me just tell you guys. Can you talk about room temperature, Doc? We're just talking about 25 degrees Celsius and 1 atm, I think so. That's room temperature. That's room temperature. So basically, that's what they're talking of. So when you go Katemba, so I was saying, when you go Katemba, Kabe Marata, then in October, just know that those groceries are not under room temperature.
There's heating
there. There is something happening. Yes, sorry. So I told you that that thinking of even going for room temperature in Mandala Maningi wa dog up. My advice was just to tell you that when you think about fats, just think about those solid things. When you think about oils, just think about those liquid things. Okay, but anyway. So we can go on question number 38. Yeah, we're ending on 22:20. I think that's when we started, isn't it? We're ending at 22:20.
At
22:20 exactly. Oh, he has left us. Can someone share the screen for us? As someone is sharing the screen for us, I'll be reading out the question. The question is saying, which of the following organic compounds yields the most energy? Number 1, carbohydrates. Number 2, proteins. Number 3, organic compounds.
B, uncle.
Proteins, eh? Oh, B up. There is no B. Where are you getting the B from?
One.
Yeah, question number 38.
Before somebody finishes, you say B.
You say B. Yes, because you have a wrong leakage. Okay, Dr. Thomas and Dr. Chazemba going with I'll go with repeat.
Which of the following?
So why is repeat the one that uses more energy? Why is repeat the best? No, why am I saying the best answer? Why is repeat the best answer to you?
Is the typist.
No, question number 38.
And why not carbohydrate?
Yes, why not carbohydrates or proteins? Organic compounds.
Why not DNA?
Yes. On 37, we said what? We said 2. On 37, IV, we said 2.
Solids at room temperature pressure.
Yes, Dr. Thomas or Dr. Zemba. Okay, it looks like Dr. Zemba is not. Okay, Dr. Thomas, okay? Because of the ratio of hydrogen to oxygen in lipids is greater than that of carbohydrates. So, so how does the ratio help us? How is the ratio helpful to us when it comes to the issue of energy?
Vinapakisa hydrogen in lipids.
Okay, can I read something on the same?
Thank you very much. That would be very helpful.
Okay,
You can read the
so
report.
okay, because one triglyceride molecule yields
Mm-hmm.
3 fatty acid molecules with as much as 16 or more carbons in each one. Fat molecules yield more energy than carbohydrates and are an important source of energy for the human body.
Okay. Thank you very
Okay, I
much.
think I think we should focus more on the first sentence, which says because one triglyceride molecule yields 3 fatty acid molecules with as much as 16 or more carbons in each one. So if
Exactly.
yeah, so
So,
when you look at fats and carbohydrates, fats
okay.
are fatty acids, so to speak, are the ones that contain a triglyceride molecule.
Okay.
Yeah, I don't know. Yes, and here they are putting more emphasis on the triglyceride molecule as well as the carbons that are contained in this molecule. So they are saying that um yeah, like they're saying one triglyceride molecule yields 3 fatty acid molecules with as much as 16 or more carbons in each one. Yeah, so here it's more like that they're telling us compare carbons that are found in fatty acids as well as in some of the carbohydrates, so in a certain carbohydrates. Yeah, I don't know.
Exactly.
Let me
And well explained. I don't think I'll even say anything on this because you have explained everything. So now I just wanted to ask a question that someone might ask. Why wasn't three the
Uncle, you just read my mind. I wanted to ask the same question. What is here is organic compounds. Even lipid itself is an organic compound. Even carbohydrates themselves, okay, they are
yes.
organic compounds. So meaning you're
Yeah,
just putting
exactly. So all
everything.
these that I mentioned here, organic compounds, doesn't even make sense actually. So
Wakuchiranga wakambazana. Isn't
I'll mute.
that? The Rosemary, are we the two of us here? Or there are people? The presenter left.
Yeah,
Okay.
some are writing their answers in the comment section.
Oh. Okay, next question. Okay. That is question 53, I guess. It's not clearly visible to me, but I'm able to read something like, is it modify or whatever? What's that word? Or identify. Okay. Identify the structural isomer or isomers of glucose from the set of molecules given above. Where above?
okay? The above is. I wonder why.
The blank
On the
page.
next page.
The
On the
blank page,
next page.
Uncle.
The next page and the preceding one, they are more like reshuffled.
You can go back down. You can go back down. You find structures in page number. Where is it in page number? What? Where is it in page number 10?
At the above is KG code. Me, I thought the blank page. So I was like, wow, what a free mark.
No, on top. Why is it in? Just be checking on the page numbers. Why? Where you have page number 10? Okay. Okay. On top. You can go on top. On top. Again down. Dog prosperity. Yes, exactly. Thank you. So those are the structures now, and the question is saying identify the structure isomers of glucose from the set of molecules given below, given above. In fact, now this time it's below, given below. Which
Why
ones
don't
are
we
the
go
structures?
with maybe starting with 51, 52, 53 then?
Exactly. I think that's the best thing we can do. We can start with question 51. Give the name of the molecules C from the set of molecules given above. What is molecule C? This molecule looks funny. What's molecule C?
Okay.
What's the name of molecule C?
It has got how many carbons? 6.
Okay.
Tunaisha kupara nkoto ntuluwanu.
Okay, Dr. Zemba is going with galactose. Why are you going with galactose? Ndio macha organic chemistry. Ndio kongamosho. Why are you going with galactose, Dr. Zemba?
So it's galactose because the OH on carbon number, which one? 1, 2, 3, 4. It is
Okay.
at the top.
Okay. Thank you very much. That's a full explanation. You can go on question number 52, unless there are questions on 51.
I couldn't see the difference between B and C.
Same applies.
You are seeing twins.
Identical.
Me, I'm saying, if I'm parana.
Me, I told you always be careful of carbon number 2, 3, and 4. Those are the only difference you're ever going to find. Okay, we can now go on question number 52. I understand though. Option number 52. Identify the molecules that would combine to form the compound sucrose from the set of molecules given above.
These guys. Let them bring in words, not in diagrams.
In diagram.
Integrate from what? Galactose
You have an issue.
and glucose.
It is galactose and what?
Galactose and glucose.
GG.
It's fructose and glucose. A and
Yes.
G.
So galactose and glucose make up sucrose, right?
No. Now the issue is identifying which structure is glucose.
I think C is glucose because when you look at carbon 1 there, the OH is, I don't even see the structure.
Am I the only one who's not seeing the structures? I need to revisit them.
When you look at structure C there, the OH is down. Yeah, it depends. So we can say that it's galactose. Galactose OH mankali pamwamba on carbon 1. So now yeah, OH depends. So I don't know if you should say glucose, but galactose have.
Muntu mineko twinoto. Kali pamwamba na kali pansi. I don't differentiate them.
So it means what are remaining? You're only remaining with A and B. And when you look at B is glucose. So A plus B will give you sucrose. You know we make sucrose by A and B. So on that one, the answer is 5. Unless there are questions, I think we should let's go and solve the last question, which is question number 53. Then we will call it a night. Yes, just solving the last one because I don't want us to come back on this one, which has Doug and
Vauchiranga sivakamba lero.
So 53 is saying
the conclusion is that structure is galactose, now glucose.
The structures are A fructose, B glucose, C galactose.
Me, I think it's glucose. And then
no. Okay. Okay, C is galactose. Y is for you to know which one is glucose or galactose. Just check which one has the same orientation as carbon number 3. The one that has the same orientation as carbon number 3 makes galactose. Then the one that has an inverse orientation an inverse orientation as to carbon number 3 is glucose. That's the way you can remember them. I don't know if that.
Uncle, what are you telling me?
I'm saying on O and H, if O and H.
Me, I know it. Okay.
Okay, let me say this. If OH and H are same for carbon number 3 and carbon number 4, like C, then it is galactose. If OH and H are different for carbon number 3 and 4, then that molecule is called the glucose. I don't want to talk about Manos. I just wanted you to get the difference between B and Z. Hope you have gotten it. So the last question we're going to look at is identify the stereoisomer of glucose. Where is Doc Evan? But
she's in heaven. She's there. I found her yesterday.
Oh, I think it has been Bill's last one. Okay, question 50.
Question 50. Banko, we're gonna Baribu base.
It's dangerous. Okay. Identify the stereoisomers of glucose from the set of molecules given above. That's the last question we're looking at. Then we call it a night. This is 2026. We said 2020. Identify the stereoisomers of glucose from the set of molecules given above.
Structural isomers.
And with an idea, number 1.
Ni B na A na C.
C.
Okay. C. You can explain why C is the best answer there.
Okay.
If you
remember, I'm quiet. Feel free never doctor.
Patrician.
Okay, if you remember your organic chemistry knowledge, maybe not even this organic chemistry, but the one we learned in grade 12, we said that a structure isomer, they're going to have the same structural makeup, just different. They'll be different on one position. And if you can see, galactose and glucose are similar in all positions apart from the carbon 4, where the OH group switches. One is at the bottom, while the other one is at the top.
Okay. Thank you very much, Doc. The definition you have explained nicely is the definition for stereoisomers. So what we call a structural isomer is basically the molecule, unless it's me who is mixing up the stuff. But what I remember is when we call something a stereoisomer, sorry, a structural isomer, but talking about something that has a different structure. If
Good.
one is an aldehyde, then the structural isomer to that one has to be a ketone or a ketose, in other words. Then
Mango ketone,
what
mango.
what we call a stereoisomer is the molecule that has the same structure like glucose, mannose, and galactose. They are of the same group, which is the aldehyde, but they differ on
The
one
orientation.
carbon. Yes, exactly, in the orientation. Like for, I don't know if it means mixing them up, but okay, let me just check Dr. Shatter's notes. But this is what my memory is telling me. But they just differ on one more of epimers. Let me say more of epimers. Like for mannose, the difference there is on carbon number 2. Then for galactose is on carbon number 4. I don't know if you're getting me on that one. Yeah, more of in space. So the optical isomers is also becoming the stereoisomers, something like that. But basically, when you talk about structural isomers, we're talking about molecules that have different orientation, like different structures actually. If one is aldehyde, the other one is ketose. So you usually be asked questions on mannose and galactose. I think that's one that I like asking. So an example of then the other one that I talk about is maybe monomers, then the optical isomers. What else? Okay, so I'm checking on. Let me check this pattern notes. So it's okay. Shatter notes say not. Okay, I think I saw them somewhere.
Uncle, this is close to 23 now.
Yes, the meeting has. Okay, let me end it now. Okay, let me end it by saying structural isomers have the same number and type of atoms, but the atoms are connected differently. Okay. One example of this is two molecules which have the same C3H6O3, in which the carbon group is at different place in two molecules. Yeah. So exactly what I was saying. So I didn't forget, but I'd forgotten. Yeah. So what I just said is basically the case there. So you should get to know them. So in ending the meeting, someone can close for us, and if there are questions, on what we have done so far. So you can